So in today's lecture, we are going to start with the energy in the SHM, right? So you may write the topic energy in SHM, energy in SHM. So this is same as the kinematics. If the particle is performing SHM, it is moving in a straight line, it has a mass m, it has a velocity or speed, so it must have the kinetic energy. Also, it must have some potential energy, right? For example, if you consider this is the spring block system, right? As I told you, when it is stretched or elongated by some distance and it is released, so what will happen, you tell? If this is the plus A, this is the minus A, if it is released to this point and it is released, right, it is elongated and released, that what will happen? It will oscillate about mean position like this. Are you getting or not? So suppose the particle is at this point at distance x, right, at time t. Suppose it start its motion right from t is equal to 0, it is at mean position. At t is equal to t, the particle is at x is equal to x distance. Are you getting or not? Okay, so at this point after time t, right, the displacement is a sin omega t, no doubt. The velocity is a omega cos omega t, right, and the oscillation is also, right, minus a omega square sin omega t, right. This is the displacement, velocity and oscillation, right. So it's kinetic energy, it's kinetic energy. The energy in SHM has the sum total kinetic energy. Total energy is the kinetic energy and the potential energy, which is called the mechanical energy. All right. So if you write the kinetic energy at any point, so kinetic energy at any point is given by half mv square. If the velocity you are taking in terms of time t, so this is half m a omega is a omega cos omega t, and this is whole square, right? So this is equal to half m a square omega square cos square omega t. Is it clear or not? Right. Listen, one more thing. Half m omega square into a square cos square omega t, right? This is the kinetic energy as a function of time t, right? Listen, one more thing. What is this m omega square, right? If you turn your pages, right, where the derivation is 2 is equal to 2 pi root m upon k, the time period of oscillation of this spring mass system, right? So the k is equal to m omega square we got, right? So this m omega square is equal to k is also called the force constant or the spring constant in this case, right? So m omega square is nothing but k is equal to m omega square, and this is called the force constant, right? Force constant in the SHM. So this is half k a square cos square omega t. So this is the kinetic energy as a function of time t. Is it clear or not? One important thing, you tell me, please listen, what is the graph of the sin omega t? This is the graph of the sin omega t, right? What is the graph of the cos omega t? The graph of the cos omega t is this. All right, this is the graph of cos omega t. What is the graph of sin omega square t? The graph of sin square omega t and graph of cos square omega t, right? Copy this, all this thing, and draw this two graph, right? This is your rubber. First copy this. Listen one thing. In general, most of the student and teacher, what do they do in the mathematics also? If this is the sin square omega t, the graph of sin square omega t, they think that just they make it, right, all the things positive, right? The lower half is turned to the upper half. In the same way, this is the cos square omega t. Is it clear or not? But it is wrong, right? The sin square omega t, right, and when the cos square omega t graph you draw, so although the shape is similar to this, but here it is right, there is no sharp corner, right? The function is differentiable at these points. So this is the correct graph of the sin square omega t. In the same way, if you draw the cos square omega t, the graph is like this. So that's the thing I want to tell you. Are you getting or not? So this is the correct graph of sin square omega t and cos square omega t, right? So here, if you are getting the kinetic energy as a function of time t, right? Half ka square cos square omega t. So how to make the graph of the energy, right? So this is the kinetic energy as a function of time t, and if you make the graph between time, so the graph is like this. Oh, sorry. The graph is like this. This is the kt and t. The graph start from here. It goes like this. Is it clear or not? Like this. So this is the thing. So that's the thing I want to tell. So listen, one more thing. At t is equal to 0, if you put at t is equal to 0, the kinetic energy is half ka square, and it is the maximum kinetic energy. What is the maximum kinetic energy? Ke max is equal to half ka square. So at t is equal to 0, the kinetic energy is maximum, and its maximum value is what? Half ka square. Are you getting or not? When it is at t is equal to 0, at t is equal to 0, its speed is, say, maximum. Speed is maximum. And what is the maximum? Say omega. Right. So what is the maximum kinetic energy? The maximum kinetic energy you can find at the mean position half mv square, and half m, what is v? Say a square omega square, and this m omega square a square, you will always remember the m omega square is equal to k is equal to force constant. So this is half ka square. So from this equation also you can find the same thing. At the t is equal to 0, the kinetic energy is maximum, half ka square. Now at t is equal to t by 4 here, this is t by 4. So t by 4 means the particle reaches to the extreme position. So what is the velocity? You tell me, what is the velocity? The velocity is, if you put here cos square omega t, cos square 2 pi by t into t by 4. Tell me, what is this? Cos square t, say t cancel 2 pi by 2, and cos pi by 2 is 0. So at t is equal to t by 4, what is the kinetic energy? Kinetic energy at t by 4 is nothing but 0. Initially at t is equal to 0, the kinetic energy at t is equal to 0, when you will put 0, is equal to half ka square, right? Copy this and copy this. Listen, one more thing. And again, at t is equal to t by 2, it means when it return back to this position, so speed become maximum, so kinetic energy again become maximum, right? You can put t is equal to t by 2, kinetic energy is equal to, right, half ka square, half ka square, and this is cos square omega and t, right? Cos square omega t. So it become half ka square cos square pi. The value of cos pi is -1 and its square become 1. So the kinetic energy become maximum again. At what position? At the mean position. Is it clear or not? You tell. Again, it moved to this point at the left extreme. The time is what? Say 3t by 4. Are you getting or not? Time is 3t by 4. The speed become 0. So this is the time 3t by 4. All right. This is time 3t by 4, and again time t is equal to capital T. Getting or not? So 3t by 4. When you put 3t by 4, what is the kinetic energy at 3t by 4? Is equal to half ka square cos square 2 pi by t, right? 2 pi by t into t. Small t is 3t by 4. you will get half k a square cos square 3 pi by 2, and this is equal to 0, so the energy becomes 0, right? So this is the variation of kinetic energy. At t is equal to t, kinetic energy is what? Say half k a square cos square 2 pi by t into t, and cos 2 pi is 1, so it becomes half k a square. Is it clear or not? So it becomes maximum again. So the kinetic energy varies periodically, right? It becomes maximum at the mean point, right? Mean position. It becomes 0, it decreasing continuously, decreasing speed, decreasing, it becomes 0, then it increase again, then decrease, increase, like this. Is it clear or not? You tell. Varsha, copy this. Listen one thing. If I ask what is the time period, it repeats its value from maximum to minimum to minimum to maximum, then maximum to minimum, minimum to maximum. So this thing is the time period. So t by 2. Right. If you consider the displacement is this, and the time period is t, and its frequency is f. Right. So what is its frequency? Its time period is, right, kinetic energy time period is t by 2, and therefore its frequency is double. Its frequency is double, right, that of displacement, right? If you consider the displacement, its frequency is double. You understand this thing? So this is the variation of the kinetic energy. If you want to ask any doubt, you can please tell. Right, copy this. This is the variation of the kinetic energy. The other energy, listen one thing. It has the kinetic energy, and what is other energy? Say potential energy, and the sum is called the mechanical energy. So the second type of energy is, you may write potential energy, right? Potential energy. What is the potential energy? You will say at any time, listen, when it is maximum, what is the elongation in this spring? Say 0. So no energy stored. When it move to this, right, the elongation is increasing, velocity is decreasing, and the elongation is increasing, so potential energy is increasing. At any time t, the potential energy in the spring is half kx square, or this is also called the potential energy of, right, in the SHM, where k is equal to m omega square. You will always remember, right? You can turn your pages, right? You in the derivation, the k is equal to m omega square relation we are getting, right? So half k, right, this is a square. What is x? The value of x is a sine omega t. All right, so this is a sine omega t ka whole square. So this is half k a square sine square omega t. So if you think, this is the potential energy as a function of time t. Again, at t is equal to 0, t is equal to t by 4, at t is equal to t by 2, t is equal to 3t by 2, 3t by 4, t is equal to capital T. Right, you tell me, when you put t is equal to 0, what is the potential energy over here? Say 0. Right, what is the potential energy at t by 4? Half k a square sine square 2 pi by t into t by 4. Please tell. This is pi by 2, it become maximum, right? T will cancel out, sine pi by 2 1, so half k a square. So at this point, the potential energy is maximum, while the kinetic energy at this point is 0. And t by 2 is equal to half k a square sine square, yes, 2 pi by t into t by 2. It becomes sine pi. Sine pi value is 0, so it becomes 0. Again, 3t by 4, when it reaches, the compression is maximum, and the potential energy 3t by 4 is equal to half k a square sine square 2 pi by t into 3t by 4, right? And this is 3 pi by 2, and sine 3 pi by 2 is nothing but equal to pi plus pi by 2 minus 1, but it is a square, so it become half k a square. Is it clear? At capital T, it become half k a square sin square 2 pi by t into t. So it becomes sin 2 pi, and soon sin 2 pi becomes 0, so its potential energy becomes 0. Is it clear or not? Now, if you draw the graph between potential energy as a function of time t, so right, so the variation is sin square omega t. If this is sin t, so its sin square omega t's graph is like this. So the graph is like this. All right. At t is equal to 0, the potential energy is 0. At t is equal to t by 4, the potential energy is maximum equal to half k a square. At t is equal to t by 2, it is at mean position, particle is mean position, no elongation or compression, the potential energy 0. Again, at 3t by 4, right, over here, the potential energy is maximum, then at t, the potential energy becomes 0. Is it clear or not? Again, what is the time period? Time period is t by 2 and the frequency is 2f as compared to, right? You may write this statement for this also. Are you getting or not? Copy this. So this is the variation of the kinetic energy. This is the variation of the potential energy. When kinetic energy is maximum, potential energy is minimum, right? And when potential energy is minimum, kinetic energy is maximum. So if you find total energy or sum of Ke plus Pe, right? The total energy is nothing but total energy is equal to Ke as a function of time t, Pe as a function of time t, right? This is the Pe. So what is the kinetic energy as a function of time t? It is equal to half k a square, right, cos square omega t plus half k a square sin square omega t. So if you take common half k square inside bracket, you will get sum of sin square omega t plus cos square omega t. It means if you think total energy as a function of time t, right, it is equal to constant. That is, total kinetic energy is constant. It does not varies. Only the thing is that right, total energy is constant only during SHM. Only during SHM, kinetic energy is converted into potential energy, and potential energy is converted into kinetic energy, so that, right, so that total mechanical energy remains constant. Energy remains constant. Is it clear or not? Total mechanical energy remains constant. Is it clear? Tell me. Right. Now, if you draw the graph of the kinetic energy and the potential energy, right? Suppose this is the time t. The kinetic energy was the maximum like this. Fine. The kinetic energy is maximum like this, right? And if you draw the graph of this is the kinetic energy variation and this is the potential energy variation, right? Like this. At t is equal to 0, this is the kinetic energy, right? And the total sum of the kinetic energy at t is equal to 0, kinetic energy is what? Half k a square, and the potential energy 0. At t is equal to t by 2, this is the time t by 4, the potential energy increasing and it become maximum, half k square, and the kinetic energy become 0. Then in next time interval t by 4, it become t by 2. The kinetic energy at the mean position increases and the potential energy decreases. Is it clear or not? But if you find the total energy graph, right? This is KE, this is PE, this is KE, this is again, right, PE, but this is KE. But if you add them, the total energy is constant. This is the graph of the total energy, right? This is the variation of kinetic energy, variation of potential energy, but this is the variation of total energy. The total energy remains with time t constant. It is clear or not? You tell. Total energy is constant. So its time period is infinite, right? Its time total. If they ask what is the time period of total energy, say it is infinite. Are you getting or not? Copy this. So in this case, what I told you that in the simple harmonic motion, when the particle is performing SHM, K is converted into P and P is converted into KE. So listen one thing. These are the times, right? When potential energy increasing and the kinetic energy decreasing, and they become equal. So can you find these times? These times. How to find? The kinetic energy is this, potential energy is this, when kinetic energy become equal to potential energy. So what are those type? Half k a square cos square omega t is equal to half k a square sin square omega t, right? So the tan square omega t is equal to 1. All right, they will cancel out. Sin square omega t and cos square omega t, right, is equal to 1. What does it mean? Sin omega t is equal to plus minus 1 because its square is over there. So omega t value may be equal to pi by 4, right? It may be equal to 3 pi by 4. It may be equal to 5 pi by 4, right? Pi by 4, 3 pi by 4, pi by 4, 2 pi minus pi by 4, that is 7 pi by 4, right? 9 pi by 4, like this. Fine. Because tan 45 1, tan 345, tan 135, right? Tan 3 pi by 4 is equal to what? Tan 135, it is equal to minus 1. And the minus 1 square is equal to what? Say 1. So it is equal to what? 2 pi by t. So pi 2 pi by t into small t, right? Omega t is equal to what? 2 pi by t into small t. So when you will calculate 2 pi by t into t is equal to pi by 4, right? So the t value you will get, say t by 8. So this is the initial value, right? From 0 to t by 4, at t by 8, initially the kinetic energy and potential energy from starting, it become equal. Then what is the next time? Omega t put equal to 3 pi by 4 is equal to 2 pi by t into t is equal to 3 pi by 4. When you will simplify this, pi will cancel out. So t is equal to what? 3t by 8, right? 4 to 8. So next time is what? Say 3t by 8. What is the next time? Say 5t by 8. How would you get? Put equal to omega t is equal to 5 pi by 4. Omega value is 2 pi by t is equal to 5 pi by 4. Pi will cancel out. Multiply by 5t, 4 to 8. So this is 5t by 4, 8. Right. So they will ask this question from initial position, from mean position, at what time the kinetic energy become equal. Answer is t by 8, 3t by 8, 5t by 8. For example, if this is the initial position and this is the extreme position at t by 4, so somewhere between this, right, like this, not just in the mid, right? It is a, it is 0, right? So not at mid, but at the time t by 8, right? From here, this is the time t by 8. Here the kinetic energy and potential energy become equal. Again, listen one thing, when it will come back to this position, right? So the total time is what? This is the total time. So this is 3t by 8 is the time interval when this energy become again, kinetic energy become equal to the potential energy, right? Copy this. So now see the energy in the SHM in terms of displacement, right? Energy in terms of displacement, right? Energy in terms of displacement. Fine. So as I told you, if this is the spring block system, right? When you elongate this and release, it will perform SHM, right, between -a to +a. Are you getting or not? So what is the displacement? The displacement is x. So what is the potential energy? Therefore, potential energy is what? Potential energy is equal to half k x². All right, half k x², and kinetic energy will be equal to half mv². So let's see first the potential energy. If you draw the graph, right, just below this, right, potential energy versus x. So potential energy depends upon the x² like this. So what will be the graph of the potential energy? The graph will be like this. Understood? Like this. This is the +a, this is the -a, this is the x is equal to 0. Are you getting or not? You tell. This is the variation of the potential energy. Fine. Listen one thing. If you put this is the potential energy, you may write as a function of x. If x is equal to 0, what is the value of the potential energy? You tell. The potential energy in the mean position is 0, right? At x is equal to plus minus a, when you put plus minus a, whether here, right, plus a or minus a, the energy is half k². At plus a, the energy is half ka², minus a half k². Are you getting or not? And this is the variation of the potential energy, right? At the mean position it is 0, at the extreme position it is maximum. Now if we see the kinetic energy, what is the kinetic energy in terms of x? Say half mv², and the v is nothing but omega root over a² minus x². So if you put the value of v over here, half m omega root over a² minus x² whole square is equal to half m omega square a² minus x². You will remember this is the spring constant, or you can say the force constant of the SHM, right? This is half k a² minus x². This is kinetic energy as a function of x. And if you know the parabola, right, if you don't know, then you will learn in the mathematics. This is the downward parabola equation, right? For example, if you put x is equal to 0, x is equal to 0 mean at here, so the kinetic energy is maximum and it is equal to half k² minus 0, right, is equal to half ka². While as x is increasing, the kinetic energy is reducing. In this case, the x is increasing, the potential energy is increasing, right? So x is equal to plus minus a if you put at the extreme position. So half k a² minus a², right? It is equal to 0. And if you draw the graph between the kinetic energy and the displacement, right? This is the kinetic energy. This is ke as a function of x, right? X is equal to 0. This is half ka², and x is equal to minus a, x is equal to plus a. The kinetic energy is 0. You understand or not? Please tell. This is the downward parabola. All right, this is the downward parabola like this, right? And this is the upward parabola, right? Copy this. So this is the potential energy variation as a function of x. This is the kinetic energy function of x, right? When you find the total energy, right? I'm writing here the total energy. After this, you can write the total energy. The total energy TE is nothing but potential energy KE plus PE. The kinetic energy comes to be half K A square minus x square, and the potential energy is half K x square. Fine, that is the thing. So if you combine them, write half K square minus half K x square plus half K x square, multiply by half K inside. So then the total energy, again you will get half K A square, right? If you see, this total energy is always constant. What does it mean? Kinetic energy is converted into potential energy, and the potential energy is converted into kinetic energy, right? You can make this graph like this. This is the plus A, right? This is the minus A, right? So this is the kinetic energy variation, and this is the maximum energy, and this is the potential energy variation. Are you getting or not? So this is potential energy, this is kinetic energy. At x is equal to 0, the potential energy is minimum and kinetic energy is maximum, right? And the potential energy increases at x is equal to A. The potential energy become half K square and the kinetic energy reduces to 0. Are you getting or not? In the same way, in the left extreme, right? This is x is equal to 0. Kinetic energy become here 0. At the extreme position, the speed is what? 0. And its potential energy increasing and it become maximum half K square. While if you take the total energy, right, KE plus PE, the total energy is always constant, right? The sum of kinetic energy and potential energy, right? This is the total energy. Are you getting or not? So this is the variation of the total energy. Listen one more thing. In the same way, they will ask the position, right? Which position they will ask? Where the kinetic energy and potential energy become equal. In between these two positions, in between x is equal to 0 to plus A and minus A to x is equal to 0, there will be some position where the potential energy and kinetic energy PE, and I'm writing it is if KE and PE are equal, right? So what is the kinetic energy? Half K A square minus x square is equal to half K x square. So K by 2 will cancel out. So A square minus x square is equal to x square, and it is equal to 2x square A square. So x square is equal to A square by 2 and x is equal to plus minus A by root 2. What does it mean? It means this is x is equal to plus A, right? X is equal to plus A. This is the position plus A upon root 2 where the KE and PE are equal, and this is equal to what? Minus A by root 2. It is minus A. Fine. So here the KE and PE are equal, right? And its value will be half, right? 1 by 4 half K square, because both are equal. And our total energy is what? Total energy is half K square. And if KE and PE are equal, so what is their value? So both are equal. So you may write 2KE is equal to half K square. So the kinetic energy at this time will be 1 upon 4K square. And this is also equal to the potential energy, right? So here it is just half of the maximum value. And this position is half Ka square, 1 by 4 Ka square. All right. And the total energy is what? This is the graph of the total energy. This is the graph of kinetic energy variation. This is the graph of the potential energy variation, right? And these graphs are parabola, parabolic variation. This is downward parabola, this is upward parabola, right? Copy this. So read this question. In this question, they are asking in SHM what fraction of total energy is kinetic and fraction when displacement is half of the amplitude, right? It is a by 2, right? The particle is over here. So they are asking kinetic energy and you have to find the potential energy. You tell me the total energy is what? Say it will remains constant. Only the kinetic and potential energy will convert into each other. At this thing, the potential energy, I will use the formula half k x square in terms of x, right? So the potential energy is half k. X value is what? A by 2 whole square. This is 1 upon 8 k e square. And if you write the kinetic energy, what is the kinetic energy? Half k a square minus x square. If you put x values a by 2, you can get a square minus a square by 4, right? And this is equal to 3 by 8 ka e square. So this is the kinetic energy. Now in the first part, what they are asking? They are asking the fraction of, right, kinetic and potential energy. So what is the fraction of kinetic energy? Fraction of kinetic energy is nothing but kinetic energy divided by total energy, right? So the kinetic energy is what? 3 by 8 ka e square and the total energy is half k square. So the answer is 3 by 4. So at this time 3 by 4 part is in the form of kinetic energy, and if you want to find the fraction of potential energy, so the potential energy divided by total energy is half k a square, fine, and the potential energy we have found 1 by 8 k square is equal to 1 by 4. So this is the fraction of the kinetic potential and fraction of kinetic energy. If sometime they ask the percentage energy of how much percentage of kinetic energy and percentage of potential energy, you just multiply by 100. Otherwise answer is this 3 by 4 and 1 by 4, right? Second part, the second part we have done at what time of displacement ke and pe are equal. So I told you half k a square minus x square is equal to half k x square. It will cancel out. 2x square is equal to a square. The x is equal to plus minus a by root 2. So these are the displacement at which the kinetic energy and potential energy both are equal, right? Copy this.